Oh, um, so guess what I forgot? I forgot to put up your guys' chapter 5 stuff, which I did just before this, maybe an hour before. So that means that the assignments that were supposed to be done like today or something like that, I moved them to Friday. Um, Everything else got moved a week back. So nobody's going to get penalized for it. At least not penalized uh, by their late passes. Okay. I think late passes we're okay with for now. Everybody's got their good number, good hefty number, and people are catching up, so that's good. Okay. Um, so let me do a quick review about this stuff, right? So for 5.2, we were going to start talking about the unit circle, okay? And in particular, we're going to start talking about the most fundamental functions for trigonometry, and that's the sine and the cosine function. But first, before we wanted to do that, we had to cover a little bit of basic geometry, and that was this thing right here. It was the Pythagorean theorem. Um, so basically, what that said is if you had a right triangle, like the one that we have um, right here, uh, then the sum of the legs squared had to be the hypotenuse squared. Um, so simply that means a squared plus b squared is equal to c squared. Everybody should, if you haven't played around with it from high school, you should at least remember it from back then. Um, so we did a quick example over here for it, just so you guys can see how it worked out, because we're going to use that a fair amount, like a lot, a lot, a lot from here on out. Um, the next thing we did was we moved on to the unit circle. So the idea behind the unit circle is that it's a circle with radius 1, right? So if we look at right here, right, the distance from right here, from this middle point all the way outside is 1, okay? That is the definition of the unit circle. Um, there were the 4 quadrants of a unit circle, 1, 2, 3, and 4, right? Um, and then we were getting into what the heck sine and cosine were, right? So it's basically uh, if you are given an angle, right? If you are given an angle of, say, degree t, right? Then uh, the cosine was the x and the sine was the y. Basically, the cosine told you how much horizontally, how much left and right you had to go to get to a specific point up here with a certain radius. In this case, it's radius 1, right? And sine of t was how much vertically you had to move in order to get to the same point that we were talking about, right? So uh, sine told us how far up and down, cosine, how far left and right. The best idea I can give you guys for how sine and cosine really work, or the best sort of analogy toward them, is sort of an Etch-a-Sketch. So if you guys remember the Etch-a-Sketch, right? Um, this one down here, that knob, right, did an up and down, right? And then this knob over here sort of just did the left and right. You know, if you guys remember that. Um, so the sine one would be the one that told you the up and down, right? And the cosine one would be the one that would tell you the left and right. So depending on the radius, depending on how far out you went, right? The sine would tell you how far to turn this knob, or sorry, the cosine would tell you how far to turn this knob, and then the sine would tell you how far to turn the other knob, to go up and down. Make sense? So there's the idea behind sine and cosine. Now, um, that automatically, here's where I left off on on Monday. Let me get rid of all my signs here. There we go. Okay. So that in itself leaves this big triangle that's right here. This one right here, right? With some angle t, right? So that automatically sort of tells us how to find the values of sine and cosine if we are given a triangle of some sort. And the way that we remember that is by this thing SOHCAHTOA, okay? It's a mnemonic. It's what people remember when they need to find out what to put where for a triangle. So S is the sine. Let me actually write it. Sine is equal to the opposite over the hypotenuse. The cosine is adjacent over hypotenuse. And the t, we're not going to get into this one too much yet, but we will. The tangent function is equal to the opposite over adjacent. Okay? So let me move over here really quickly. I'm going to draw a nice triangle here. Whoa. Not exactly what I wanted, but let's try that again. How about we not? Okay, how about we do, I need to shape. How about that? Come on. Oh. So if we have an angle T here, right? And let's say we have an A, a B, and a C, right? So this side, the longest side, is always called our hypotenuse. Okay, and depending where the T is, depending where our angle is, that's what determines our opposite and adjacent. So in this case, sine of an angle T, right? Sine is opposite over hypotenuse, so that's going to be my B divided by C, right? My cosine of T is going to be my adjacent over my hypotenuse, so it's going to be A over C. And then my tangent of my angle T is going to be opposite over adjacent, which is B over A. So notice how, depending on where the angle is chosen, right, we have to make the decision of which one is opposite and adjacent from that point. Okay? And that is exactly what's going on here. So sine is equal to opposite over hypotenuse. The adjacent is equal to adjacent over hypotenuse, and the tangents are equal to opposite over adjacent. So if we use this triangle over here, right, notice that this has been broken up into an x and a y, right, with our hypotenuse being 1, so let's not forget that. So don't you love it when you choose a color and it says, no, you want this one. There we go. So our hypotenuse is always 1, right? So that means that this distance here is x, Whoa. Oh, it's still doing into shape. Okay. So this hypotenuse right here is 1. This distance here is x. And this distance here is y. Cool. So then if my angle here is t, then my adjacent is going to be my x, right? And my opposite is going to be my y, and my hypotenuse is going to be that 1. Okay? That's where we get this stuff from. Okay? So for now, for the easy ones here, right? I'm giving you guys a point, and I'm asking you guys which one is sine and which one is cosine, right? That can be had just from right here. So thankfully, all of these are on the unit circle. So all of these, the radius here is still that 1, right? So sine and cosine are given by specifically just these 2 points. So sine of some angle t is the y from up here. From up here. Okay. So the sine is going to be root 3 over 2. And the cosine of that same angle is going to be 1/2. Okay. Same thing here. The x always gives the cosine, and the y is the y. So sine of t for this angle over here is going to be root 2 over 2. Cosine of t is going to be negative root 2 over 2. Okay. So let's go ahead and do 2 more. Okay. Cosine of 90 and sine of 90. We all know where those are. So if we have our unit circle, let me actually. Whew, there we go. So we all know where 90 degrees is, right? That is this bit right here, this point up here. So we know that that point is 0, 1. Got it? So our sine of 90 degrees is going to be the y coordinate, which is 1. And the cosine of the 90 degrees is going to be 0. And we're done with those. Same thing here, right? So pi, the angle pi, is way over here, right? So this we know is 0 degrees. We have to go that far around for pi degrees. Okay. We know this coordinate is -1, 0. So cosine of pi is going to be -1, and sine of pi is going to be equal to 0. That easy. Okay. 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 One of the bigger identities that we're going to start with is this one. And it's called the Pythagorean identity. Exactly why you think it is. It's because of the Pythagorean theorem. So let me actually do the shape over here. So here's our X and our Y. And let's say, here's our circle, right? Okay. From before, right, we have the radius of this is always going to be equal to 1, right? The triangle that pertains to it, right, we have the x being, sorry, not sine, cosine. And my pen wants to be smart today. Oh, the whole thing wants to be smart. It completely shut out the OneNote. There we go. It's back. There we go. Okay. Sorry, you guys. Sometimes my computer likes to tick me off. Okay, so we know that this point right here, cosine of t, sine of t, is going to be the coordinate for it, given that this is the angle t, this being a right angle, right? Which means this leg right here is cosine t, and this piece right here is sine of t, right? And so now we'll use the Pythagorean theorem from the very get-go to get this equation, right? So then this thing squared has to be, sorry, this thing squared plus this thing squared has to equal my 1, right? And that is exactly what it says right there. So this is from Pythagorean theorem. Okay, so if you ever forget it, no, it's from the Pythagorean theorem. So it's always the two legs squared. So this squared plus this squared has to equal my hypotenuse squared. Okay? Okay. Notation abuse. Notice how when I write an exponent with a cosine, right? The cosine now, or the sine or the cosine, the square is actually inside, not outside. So the notation abuse here is this. So when we talk about cosine squared of t, right, this is equal to cosine t, that whole thing squared. Okay, which is not the same as cosine t squared. That's only for the inside. Does that make sense? So this is where the parentheses make a big difference. Okay, so if you want to write this, that's fine. If you want to write this other one, that's fine. But know that that is not the same as this over here. Okay, whereas here in this one, the square, well, the square only hits the t and not the cosine. Got it? Okay. So here we go. We're getting down to the point where we can find the other one based off of we can find either sine or cosine knowing the other one. Does that make sense? So if, let's say, cosine is in the fourth quadrant, so like I said, these things have quadrants, right? So 1, 2, 3, 4. So if cosine is in the fourth quadrant and cosine of t is equal to positive 24 over 25, what is sine of t? So what I'm going to do, just so we know where we're at, is I'm going to go ahead and draw my unit circle. Okay. Not the best unit circle, but close enough. How about I make it, there we go. Okay, so we want 24 over 25, and it's in the fourth quadrant. So this is 1, 2, 3, 4. So we know that we're over here somewhere. Okay, and we know, well, we know cosine of it is 24 over 25. So we know this is 24 over 25. What the heck is sine? Right? We know this is a unit circle, so this is going to be 1. Okay. We now use Pythagorean theorem to find the rest. So we know 24 squared over 25. Let me do this the other way. 24 over 25 squared plus, let's give this thing a side. Let's say this is b. B squared is equal to my hypotenuse squared, which is 1 squared. Right? So what I'm going to do is this thing right here, we're just going to play around with this just as we do algebraically. We grab that, throw it to the other side. So minus 24 over 25 squared minus 24 over 25 squared. So b squared is equal to 1 squared, which is 1, minus 24 over 25 squared. So that means b squared is, let's see, I need my calculator. 1 minus 576 over 625. So let's continue it on over here. So b squared is, now I'm going to do common denominators. 625, 625, minus 576 over 625. Now we get to subtract the tops. 625 minus 576, 49. $625, 49. So b squared is 49 over 625. Last step, square root, square root. So b is equal to 7 over 25. Since it was sine that we were looking for, and that's the thing that was missing, we have our answer. So sine of the angle T is equal to 7 over 25. And we are done. Okay. Okay. So what I want you guys to do is we're going to practice SOHCAHTOA. So this thing right here, all of this right here, okay? We're gonna go ahead and practice it a little bit. So I'm gonna break you guys out into your groups, and we are going to try these problems out. Try to do sort of like the same process that's up here. You will need to find a triangle, and you will need to um, uh, solve for a missing side. Let's put it that way. Yeah. Okay. So I'm going to break you guys into your groups. I want you guys to try it out. The group number, Joe.
Wait, so in that
Yeah.
previous example, since we're in quadrant 4, shouldn't the sign be a negative number?
Yes. Thank you for catching that. You are correct. So just how Joe just said just now, we are in the fourth quadrant. So that number that we found, right, is going to be negative. So what I found was for this triangle, right? I found the missing side, but that wasn't taking into account the quadrant that we were in, right? Which in this case, right, is negative. So we need to make sure that our sign for that is also going to be negative. So thank you, Joe.
So wait, so the math's not necessarily going to reflect that. We just have to remember what quadrant we're in after we solve.
Exactly.
And
Yeah. Yep. So the thing that I hadn't taken into account is the fact that we were in the fourth quadrant. Yeah.
cool, thanks.
Uh huh. No, thank you. I would have left it as positive. Okay. So I'm gonna break you guys up into your groups. I want you guys to try these out. Come on. The group number that you're in will tell you what problem you're gonna do. Okay. Let's see. Yeah. Okay. Okay.
Words that are hard on burning. They're gonna say the same shit's gonna happen.
You guys. Good, bad. Guessing you guys are still maybe working on it. Or are you guys all done?
What's up, Professor?
You guys good? Hey, what's up, Abel?
Not much. I got to 144 over 1,225 plus 1 squared.
Okay.
Now, what do I do with that 1 squared?
Well, what's 1 squared?
1.
Okay.
So just add it?
Yeah. So you're gonna need to do common denominators.
Oh, yeah. Okay, yeah. Nice man bun.
I know, right? I had said when was it last before spring break started?
Yeah.
March was the worst time to put off a haircut.
Looking
Now I gotta
smart.
rock the man bun, man.
That's cool.
Yeah.
It's better than being blind, I'll tell you that.
Yeah. It's much better than you know, I was telling my wife, like, had this virus not been around, I would have not been seen, like, not even drunk with a ponytail like this. And now I've been going to get food, going to groceries, the freaking man bun on my head.
It
And now
seems
I got
like no one really cares about their appearance anymore. They're like,
yeah, no. Yeah.
Wait, so how do I do the common denominator thing?
How do you do common denominator? So if you check the so you got something like you probably got something like the common denominator would be that denominator that you got from the sine of t. So it's going to be that 35 squared, which is something huge. What's 35
So that would
squared?
be my common denominator? That over
Yeah.
1?
No, well, it'd be 1,225 divided by 1,225. So if you check my example, let me see if I can put up my example again. Where am I?
Yeah, I got the example. I just don't know how you got that. Is that how it's always going to be?
Yeah.
Okay.
So see where in my example, I have b squared is equal to 1 minus 576 over 625. Right? And that 1 is what turned into the 625 over 625.
Okay.
Got it?
Yeah, got it.
Cool.
And then I would just add these or add the top.
Yep.
Okay.
Well, it's supposed to be a subtraction, I think.
It's because it was already negative, and then I subtracted it to
Wait, hold the phone. When you square a negative, it turns positive, right?
So I was supposed to square it before I subtract it to the other side.
Yep.
Okay.
Mm-hmm.
So that would just turn it negative.
No, well, yeah, exactly. It'll turn that thing negative.
Bust down calculator.
Yeah. All right, I'm gonna go visit another group really quick.
Okay. Thank you.
Mm-hmm. You guys doing all right? I'm guessing you guys are flying solo.
No, we got different answers. We're just checking them right now.
Oh, okay.
Yeah. We
Yeah,
got,
so it turns out the uh, another group, they I bet you your guys' answers are off by just like a negative in the process somewhere.
no, we both got fractions, and he said he forgot to square it, so I think he's redoing it. I got to the square root of 34 over 5. I don't know if that's correct, but that's what I got with the math.
I think you added somewhere where you were supposed to subtract.
Yeah.
Yeah.
'Cause
I think you're supposed to get 16 over 25.
16.
The square root of 16 over 25.
Let's see here. 16.
So I think
But well,
yours amounts to your guys' problem probably amounts to an arithmetic mistake.
well, that would make sense if the cosine was a positive number, wouldn't it? But since it's a negative number, isn't
Mm-mm.
the numerator going to be higher? Because we're adding it to the other side. It's like 1 plus the negative 3 over 5
I think it's supposed
squared.
to be there. Okay, it's 1 minus.
Oh, because we're supposed to do the exponential math before we subtract it from the other side.
Yeah.
Okay. Well, there
Yeah.
we go.
There we go.
Duly noted. I'll fix that right
Mhm.
up.
Yeah. So PEMDAS, exponents go first before you start subtracting and adding to different sides.
All right.
Yeah.
Got me.
So yeah, you guys
me.
made the same mistake as the other group.
Okay.
Yeah.
We'll fix it up.
Okay.
Thanks.
All right. Uh-huh. I'm gonna go let's see, terrorize somebody else. Let's see. Yeah. Okay, I'll see you guys back in a bit. You guys. Boom.
Oh. I think I know what I'm doing.
That wasn't very confident.
I joined like right before you put us into our breakout group, so I was like, huh?
Yeah. It's okay. Get through as much as you can.
They explained it pretty good.
Yay.
I got 41. I don't know if that's right or not.
For the hypotenuse?
Yeah?
Yeah, me too.
Okay.
Yeah.
So for the sine, you have to do opposite over hypotenuse. So opposite
Yep.
is 40 and hypotenuse is 41.
Okay.
Yep.
So to find the sine, you would just have to plug in the numbers. You don't really have to do anything else.
So I think you guys are doing it a separate but equivalent way. So I'll cover huh?
There's another way to figure this out?
Yeah, I think you're doing it. I don't think from the sounds of it, you guys aren't doing it like I did in the examples. And that's perfectly fine. You're actually doing it another way that I'm going to show you guys in a little bit.
Oh, okay.
I think you guys found all the sides of the triangle, and then based on the angle, that's the thing that you did.
Yeah.
Yeah. Which is, like I said, which is equivalent.
Okay.
Yeah. All right. I think I'm going to call you guys back.
Okay.
Okay. We still got a couple break rooms out and about.
No, it's b squared equals 16 to up.
I got you mid explanation there. Okay. Whoa. Yes, I know that. Okay. Share screen. This one. Okay. So I'm going to go ahead and do a couple of them. Okay. I'm going to go ahead and do, let's do, where's my pen? So I'm going to skip the very first one. I'm going to go ahead and do the second one. And I'll show you guys a different way to do it for number one. Let me do number two the same way that I did example 3 from above it, okay? So we know tangent of t is 40 over 9, and it's in the first quadrant, okay? Actually, no, I'm going to show you guys how to do this. This is going to be the second way. Then I'm going to show you guys how to do it. Let me stop my video. There we go. Okay, so there are these definitions here. Where are they? Here. Those blue ones. Okay. Sine is opposite over adjacent. Cosine is, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we're going to use that here. So first thing we're going to do, it's always a good thing to do this. Go ahead and draw your unit circle, right? And tangent is in the first quadrant. So what I'm going to do is I'm going to draw a rando triangle in here. Right there, okay? And we know, so this is going to be our angle T, right? Tangent is opposite over adjacent, right? So my opposite is going to be 40 over 9, right? This gives us everything we need. So then we know we need to find that thing right there, our hypotenuse. So then we go ahead and start doing the math for the Pythagorean theorem. So 40 squared plus 9 squared is equal to our c squared, right? So 40 squared, that is 1600, plus 9 squared is 81, is equal to c squared. So 1681 is equal to c squared. Take the square root of both sides, right? And this should be 41. Let's double check. Okay, so that gets us our thingamabob, our hypotenuse. Whenever it wants to erase, whoa! My computer's acting up. Okay, that gets us our hypotenuse of 41, right? And we needed to find sine, right? So sine of t, we know, is equal to opposite over my adjacent. Sorry, opposite over hypotenuse. So opposite of my angle is 40. My hypotenuse is 41. We are done. Okay, let me do one where it's in the third quadrant. Here we go. This one that's in the third quadrant. Okay. Same thing, right? So we're going to draw our little, I'm going to draw our unit circle. Bam. Okay. That's not completely straight. Okay. We're in the third quadrant somewhere, so we are somewhere in here. So again, I'm going to draw my triangle, right? We know our sine is negative 20 over 29. We need to know, actually, we need to know tangent, right? Let me do my angle T, right? So we need to find our cosine, or the x value of it, right? So we know that this is our y. This is our negative 20 over 29, right? So we're going to go ahead and use the triangle thing again. So if we do tangent, sorry, so we know sine of t is equal to opposite over hypotenuse, and that's going to be the negative 20 over 29. This one, okay, so did I just screw up? No, I didn't. No, I didn't. So we're going to use this, and we're going to fill in our triangle. Oh my God. My tablet. There. I know I had it nice and pretty before, and now it erased everything. Oh. Okay. So our hypotenuse is 29. Okay. And our sine, our y, right? Our opposite here is negative 20. So now we need to find our missing adjacent side. Okay, so then this is where we do 29 squared is equal to negative 20 squared plus b squared. We're going to call that missing side. Oh my goodness. We're going to call this missing side b. Okay, so 29 squared. Actually, let's do 29 squared. 29. That is 841 is equal to 600, or sorry, 600. 400 plus b squared minus 400 minus 400. So 441 is equal to b squared. We take the square root of both sides. So b is equal to 21. So we have our missing side now. That is 21. Okay, so our tangent t is going to be opposite over our adjacent, which is 20 over 21. Now, I'm going to make the same mistake here. I already did. So our b for our triangle is 21. But we know we are in the third quadrant, so we know that this is also going to be negative. So our adjacent was negative 21. Our opposite is also negative 21. So the also correct answer here is 20 over 21 since the negatives cancel out. And we are done. We have the 2. Have I lost people?
I just get confused about where I need to put in negatives and where I don't.
So let's go back up to the quadrants. So you always have to pay attention to what quadrant you're in. So over here, in here, the quadrants, over here, both of these, the x and the y, are going to be positive, right? In quadrant 2, right, if you have x's and y's, your y's are going to be positive, right? But since you're in the negative direction in the x's are going to be negative, right? In quadrant 3, you're in the negatives of both. So x's and the y's, both of those are going to be negatives. And then lastly, in quadrant 4, your x's now are positive, your y's now are negative since you're dipping down. Does that answer your question?
Yes, much clearer. Thank you.
Okay. Boom. Okay. Where are we at? Where are we at? Where are we at? Okay. So, we have we've gotten to a point in the class where we're going to start repeating a fair amount of the angles, okay? There are some special angles that we're going to look at right now. The ones that we're actually going to be doing a whole bunch of work with are the 30 degrees, the 45 degrees, and the 60 degree ones, okay? So that's basically this top that's this sort of like this first quadrant. This is quadrant 1. Okay. What I want to do now is we're going to go ahead and prove sine, cosine for 60, 45, and 30 degrees. Okay. Since we know the sine and cosine for 0 and 90 degrees, we're good there. But it's these 3 right here that we're going to find values for. Okay. And the way that we're going to do that is this is going to be some geometry. It's going to be special triangles, okay? And we're not going to be using any more than the Pythagorean theorem, okay? So to start, we're going to try the 45, 90 triangle, okay? We're going to try this one first. So what I'm going to do is I'm going to draw a triangle 45, 45, 90. So I'm hoping that's good enough there. So if this is 45 degrees, this is 90 degrees, this has to be 45 degrees, okay? And what we have here is what's called an isosceles triangle. And what's so nice about the isosceles triangle is both of these sides right here, this one and this one, those are exactly the same. Those are exactly the same, okay? So what does that mean? That means this. that if, let me actually move all of that over. Come on. There we go. Okay. What that means is if we, first of all, I'm going to use the hypotenuse being equal to 1. Okay. And there's a reason behind it. We'll see it in the answer. Okay. If we use Pythagorean theorem here, then that means that this A and this A, well, sorry, both of those legs have to be equal. Got it? So now, if we use Pythagorean theorem, we have something that looks something like this. A squared plus A squared is equal to 1 squared, right? We have two A squareds, so we can combine them to 2A squared is equal to 1. Okay, we can divide the 2, so we get now left with A squared is 1/2. We're just following our nose here. Okay, and last, square root. So A is equal to the square root of 1/2. We can break that up to 1 over square root 2. Okay, we don't like square roots on the bottom, so multiply square root 2 times square root 2. And this gets us root 2 over 2. And that is our final little number that we need, okay? So now, let me actually leave that as A. We have this going on. We have that A is root 2 over 2 over 2, okay? And we are done. We have our 45, 45, 90 triangle complete with the values that we need, okay? And if you notice, right, we now have, that's this triangle right here. Let me actually, I wonder if I can use my space pen. Yep, there we go. That's this triangle right here, right? That is that triangle right there. This angle right here is 45 degrees. This one is 45 degrees. And this one is the right angle at 90. Right? And that's how we get our coordinate for 45 degrees. It's root 2 over 2, comma root 2 over 2. Okay? And that comes from the 45, 45, 90 triangle, right? So, now, this one right here is done. The next two actually come from the same triangle. It's a different one, but we do sort of like the same process. We're gonna do this. Okay, what we have here is an equilateral triangle. Okay, an equilateral means all three of these sides are exactly equal. Okay, I'm going to make all three sides equal to 1. Okay, and an equilateral triangle, the other nice thing about it is all the angles are 60 degrees. Okay, I haven't lost anybody yet. Stop me if you have. Stop me if you've fallen off the bandwagon. Okay, I'm looking at the chat, making sure nobody's falling behind here. Okay. So what I'm going to do is I'm going to grab this triangle and sort of slice it straight down the middle. I said say it straight down the middle. Okay, so now this becomes two triangles, right? And specifically, this happens up here. One of these angles is 30 degrees, and the other one is also 30 degrees. Okay? Okay, this automatically gets us one nicety that now, since we divided the triangle in half, each one of these lengths right here, from here all the way to the middle, is 1/2. Since the original length was 1 and we split it in half, it's got to be 1/2. Okay? And this sort of gives birth to what we call the 30, 60, 90 triangle. Okay? And I'm going to go ahead and draw it. So I'm just going to take one of these, right? Okay. So 30 degrees, 60 degrees, 90 degrees. Got it? So we know that this length is 1. This length over here is 1/2, right? So there's one bit that's left, and that's, let's call that the B side, right? Okay. So from here, right, in order to find that missing B side, we use Pythagorean theorem again. So it's going to be the 1/2 squared plus B squared is equal to 1 squared. And I'm looking at this triangle over here, not this one. We've used this one up. We've used it, all the goodies from it already. So we're just looking at this one in purple, okay? From here, right, it's 1/2 quantity squared. Okay, so this is going to be 1/4 plus B squared is equal to 1. B squared is equal to 1 minus 1/4. I'm going to carry it on up here. So B squared is 3/4. Take the square root of both sides. B is equal to, I think it might crash again. There it goes.
Professor, can you
Oh,
show me
come
where you
on.
got that 1/4 from?
Huh?
Can you show me where you got that 1/4?
The 1/4 came from, yeah, give me a second. My computer crashed again. Let me share the screen again. The 1/4 came from over here. So if you do Pythagorean theorem on this triangle over here, right? You're gonna get the 1/2 squared, right? Plus B squared is equal to the 1 squared, right? When you square 1/2, that's where you get the 1/4. So 1/2 squared is 1/2 times 1/2, which is equal to 1/4. That's where we get the 1/4 from.
Got it. Thank you.
Got it? Uh-huh. Okay, so now B squared is equal to 3/4. Square root both sides. B is equal to root 3 over square root of 4. But we know square root of 4 is 2. So root 3 over 2. Okay, so the two triangles that we're going to need here, right, are basically these two. Let me actually see if I can copy paste them. Not what I wanted. Okay, so the two triangles, let me just write them out. 45, 45, 90 triangle. So this one is the very first one that I did. Where if the hypotenuse was 1, then each one of these legs was root 2 over 2. Root 2 over 2, right? And then the second one is, let me see, do I have enough space? Yeah. The 30, whoa, 60, 90 triangle. Okay, and that one was the one with the longer leg. So here we have this going on. So this angle was 30 degrees. This one was 60 degrees. And this one's 90. Okay. The hypotenuse is still 1. Whoa. Hypotenuse is still 1. But now we know the rest of our legs. So this is going to be 1/2. And this is going to be root 3 over 2. Okay. These two triangles right here sum up the big ones. Funny, it circled it. These two triangles right here are what we use to get these angles right here, right? So if you take a look, we have a 30, 60, 90 triangle right here. I didn't summarize this. We have a 30, 60, 90 triangle right here. So that's where we get our legs, the root 3 over 2 and the 1/2. So our x is the root 3 over 2 and our y is the 1/2, just how we have it here. Okay, and then lastly, the other triangle is basically that same one that the 30, 60, 90, but it's now standing up rather than laying down. So that's why these two are now flipped around. Because now this is the 1/2 and this is the root 3 over 2. So to summarize, right, I put some of these down here. Okay. So depending on what angle, right, there's a sine and a cosine for them, right? So cosine are those values and the sine are those. And they're basically from those two triangles put on sort of an XY plane, right? And then punching them into the circle, okay? Now, you guys are going to be using these angles so much that at one point, you're going to just start memorizing them, and that's okay, okay? Most other instructors, they're going to tell you that you need to memorize these angles. I am not going to tell you to do that. I'm pretty sure that you guys can. I'm pretty sure that you guys are going to be using them so often that you guys are going to memorize them on your own. Okay. I myself don't ever memorize them because I remember these two triangles every time. We build the unit circle, okay? We build these angles off of these two triangles. So it's much more useful to remember these two triangles rather than to memorize all of those angles. You'll see how bad it gets in a little bit. It's not that bad, but you see how much memorization other people might require of you. Okay. Let's see. How much do we have left? You know what? Let's go on a break for a little bit, 5 minutes, and we'll come back and do the rest of this.
Professor, can you leave it on the there you
The
go.
triangle ones? That
Yeah.
one? Okay. How are people doing? Have people gone crazy yet? I'll tell you one thing. I'm tired of watching movies. That's the only thing we can do. Ah, yeah, there is only so many things. Yeah. However, it's sort of a something from psychology. Like the best thing for cabin fever is to maintain a routine, which means you're going to be doing so many, the same thing so many times in the same day. So if you have a routine, if you have something that you do every day, the same time, same day, every day, that's actually good. Yeah. Yeah, a fair amount of you guys still work, which is kind of bad. I mean, you guys shouldn't have some time off, but yeah. I haven't been out of the house like for like so long. We drive maybe 2-3 miles. As long as there's built space, yeah. I can dig it. I wonder how many of us are gonna like get out of the quarantine and be like completely socially awkward after this. Like we won't know how to interact with people. We've been locked up for so long.
Oh, so it's gonna be the norm for me.
Normal for you. We'll all be socially awkward toward everybody else. Oh man. At least it's a nice day out today. Kinder's barbecue. I went there maybe a week and a half, maybe 2 weeks ago. Oh, Korean barbecue. Oh yeah. Korean barbecue. Oh yeah. There's this place not too far off right here, pretty close to where I live. Korean barbecue. It's called like what's it called? Ohane or something like that. Um yeah. Um $30 all you can eat Korean barbecue, and they bring you more stuff, more stuff. I'm like, ooh, $30 per person, which is pretty cheap. Super cheap. And at least with me, I'll eat a freaking cow I'll get my money's worth. Jen is better? Okay. Yeah, it's down what is that, Willow Pass or something? I think it's Willow Pass. I haven't tried it. I've just gone to Ogani, that's right here. I'm gonna have to go try it just after all this is done and we're allowed to roam. All right, let's keep going. There wasn't actually too much for us to go do anymore. But we're gonna go ahead and let's finish this up really quick. It's actually gonna take me maybe 5-10 minutes. I'm gonna give you guys some practice and that's it. So the first thing I wanna do is, am I still sharing the screen? Yep, okay. The first thing I wanna do is identify the domain and range for the sine and cosine functions. They're both the same. So the domain, right? What can we plug in to sine of t and cosine of t? Is there any angle we can't plug in? The answer there is no. So the domain for both sine and cosine is negative infinity to infinity. Okay. Now the range, that is now limited, right? So remember, it goes, so for any angle t that you can think of, right? So for any angle t, it goes cosine of t, sine of t, right? So the x is cosine and the y's are sines. Okay? So the cosines only bounce from from positive 1 to negative 1 and back and forth and back and forth and back and forth, right? So that automatically gives us the range for cosine, right? And then same thing for sine, right? It bounces from negative 1 to positive 1 and back and forth and back and forth and back and forth, right? So that gives us the range for both of those. It's going to be from negative 1 to 1. Okay? So just how we were doing before, right? The x's, the domain is the numbers that you can plug in for sine and cosine, right? And those are infinite, right? And the range is the y's, the outputs of them, right? So if you plug in any angle to cosine, you'll get something between negative 1 and 1 every time, okay? And then same thing for sine. If you plug in anything for sine, the only values you'll get back is everything between negative 1 and 1, right? And that comes from our unit circle, okay? That's why the unit circle is so important, okay? Okay. This next topic right here, still about the unit circle, it gets to the cyclical properties of the unit circle. So the reason why the unit circle is so important and so useful is because it gets us a whole lot more information just from one picture, okay? And the way we do that is by using these things called reference angles, okay? And in order to find a reference angle, right, you find the angle with same terminal side inside Q1. Oops, Q. Inside the first quadrant. So we're basically going to find the equivalent angle that lives only in here. Okay. And here's where the extension of the unit circle comes in. If we find it in that one quadrant, in quadrant 1, right? All we need to know is what quadrant our actual angle lives in, and then we can just use the values from quadrant 1 to answer the original question. Okay, so for example, let's go ahead and find the reference angle for 225. Okay, so I'm going to go ahead and do the into shape. Okay, 225 is, so we know that, whoa, we know that up to here, that is 180 degrees, right? Okay, 225 is right here, specifically, that is 45-degree difference from that 180. Make sense? And there, right therein lies what's called our reference angle. So we are going to reference, whoa. We are going to reference the values for 45 degrees. So the values for 225 degrees are equivalent to the numbers that we're going to see for 45 degrees, with the exception that our values are now in Q3. Well, that's funny. It changed it into a circle. Okay, does that make sense? Okay. Reference angle of 5 pi over 3. So, same idea. I'm going to draw my axes here. I'm going to draw my circle. I'm getting better and better at this. So, I'm going to do 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So, notice how this is working out, right? So, this is pi, right? Four pi over 3, 5 pi over 3, okay? Now, to find the reference angle, I need the equivalent angle in quadrant 1. So, turns out this amount of angle right here is pi over 3, right? Which is equivalent to already this angle that's right here, right? So it turns out that the angle 5 pi over 3, the reference angle that we're going to use, is the same stuff that we're going to use for pi over 3. Making the appropriate changes for 5 pi over 3 being in Q4. Okay, does that make sense? Okay,
Lost me
so
there.
what was that?
Lost me there.
Where?
How exactly is did you get pi over 3 right there in the, not on the outside but on the inside?
You mean this one?
Yeah.
Yeah. Okay, so we know that from here to here, right?
Mhm.
Actually, let me go here. So this point right here is also 0 and 6 pi over 3. So you see how I was counting, right? So I went pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, which is rounds out to 2 pi, right? So then I had, when I got here, I was already at 5 pi over 3. So and if I add another pi over 3, I got to 6 pi over 3. So that gave me my pi over 3 that's right there.
Oh, you simplified that.
Yeah.
Okay.
Got it?
Got it. Right on.
Okay. So then that's how we find reference angles. We try to find the equivalent angle in the first quadrant. Okay? So now, I want to break you guys up into your groups again. And I want you guys to find the reference angles for these. So there's 2 pairs, right? Or there's a pair for each group. There's one in angles, right? And then there's one in radians, okay? So I'm going to get you guys to work on both, okay? Find me the reference angles for each one. So the group number that you're in will dictate what problem you guys are going to do, okay? And off you go. Move the stuff away from the printer. Can you move the stuff away from the printer? I'm going to try to print something. No, I haven't tried it yet. Need a copy of it. All right, how you guys doing?
For the top one, I got the reference angle to be 30 degrees.
30 degrees, huh? Yeah.
Originally I thought it was 60, but that wasn't right, because it didn't share the same terminal side.
Mm-hmm. Right.
And then if the bottom one wasn't a negative, I would say it was pi over 6, pi divided by 6. But because of the fact that it's negative, I don't know what to do.
No, you had it. It's pi over 6.
Okay, and that's so if it's negative or since it's negative or positive, it doesn't matter because it's still going to be that ratio is going to still be the same no matter where it is.
Exactly.
Yeah. Okay, cool.
Yep.
So, all right, cool. Right on. And I don't know why it's pi over 6. I just referred back to the example 3 diagram on section 5.1.
Yeah.
And
that's it.
Okay, cool. I don't have to do any crazy math to just kind of look at these
You just end up
diagrams.
finding, right, you just end up finding that angle, whatever that is.
All right, cool.
Cool. Okay.
Right.
You guys know what
Thanks.
you're doing. I'm gonna go bug another group. Scare the crap out of them. Let's see. Yeah. Okay, you guys good?
Not really.
No.
You guys are group 2. Oh, yeah. Okay. Why? Why no good?
So we just gotta find like the matching angle that's in quadrant 1.
Yep.
Oh. Okay, so for the bottom one, negative 10 pi over 3, would we have to go backwards?
Yep.
Okay.
And actually, the next quick check is why it becomes so important to be able to do this. Okay, I'm gonna check out another group. You guys doing all right then?
Yes.
For the most part. Okay. All right, how are you guys doing? Bryce, Ethan?
I'm trying to figure it out.
Okay.
I think I got
I'll catch up.
the first
Yeah.
one, but then the second one, I was kind of like,
Usually when people bounce over to the radian ones, the ones with the pies in it,
mhm.
that's when people are like, I don't know what to do. But it's the same thing. It's the same thing. It's just, I'm pretty sure it's because people are more confident with the angles than with the other stuff, than with the radian measures. But you got to get good at both. Oh, the puppy's there again.
Yeah, she's sleeping right next to me.
Mm. She's got the life. He?
It's a girl, yeah.
The girl, yeah. She's got
loves
the
me.
life. Yeah.
Would the first one be? Let's see, what did I write down? Would it be 90 degrees?
Yeah. Mm-hmm.
Oh, it is.
90 degrees it is, yeah.
Oh, yay. Okay, then I'm pretty sure I'll be able to understand the second one then.
Yeah.
I figure it
Okay.
out a little bit.
Okay. I'm gonna go bug the other groups.
Sounds
Okay.
good.
Okay. You guys are good then?
Yep. Thank you.
Awesome. And you guys. It's just me. It's just me. I'm gonna break it up. No, they're there. They just haven't joined. I'm pretty sure they're probably done with the problem. I'm gonna close all the rooms. Ooh, breakout rooms are cool. The breakout rooms. So I can break them up into smaller little rooms and have them do group work.
Oh, that's pretty cool.
Mm. How was it? Thumbs up, thumbs down. How you guys think you did? Okay? Me? Like, oh crap. Me? Okay. All right. Okay. Let's go ahead and do a couple of these. Okay. So I'm gonna choose like a select couple of them so I can do. I'm gonna do the 330 one. That one's for sure. So we're gonna go ahead and, as usual, right? We're gonna just find the angle to begin with. Just okay. 330 degrees. That is like this around here. Let me actually draw the thing out first. That is about right there, right? That's 330 degrees, because we know that that right here is 360 degrees if we go all the way around. So that's our angle, 330 degrees, right? Looks like that right there is just straight out 30 degrees. That becomes our reference angle here. Right? So if we need values for 330 degrees, we can go ahead and just look at 30 degrees and make the changes appropriately, right? So the reference angle here, it's going, it crashed. Sorry, you guys, my computer's acting up today. Heavily acting up today. So it crashed again. So the reference angle here is 30 degrees, okay?
Professor Leo, why did
Yeah.
you switch the angle to the other side?
What do you mean, what did I switch the angle to the other side?
The
As
red
in-
one.
The red one? So
Mhm.
I am looking for the reference angle, right? So it's not that I switched it, it's the 30, this one is the reference angle that I'm going to be using.
I thought the reference angle was the one between 330 and 360.
Yes, it is. I'm just sort of yeah, I am, let me just go ahead and do it over again. I am specifically signaling that that's going to be the angle that I'm going to be using. That's it. So the reference angle, you're right, it's this 30 that's right here, right?
Mhm.
I'm just spelling it out up here.
Oh, okay.
Yeah, that's it.
But it's still in the fourth quadrant.
Right. The 330 is still in the fourth quadrant. So remember, I'm the reference angle is the equivalent angle in the first quadrant. So that's why I'm doing the 330 again in the first quadrant rather than just having the 330 that's between the 330. Or sorry, the 30 degree angle, but that's between the 330 and the 360.
Oh, got it. It's always
Yeah.
going to be the first one.
Yep. Okay.
Mhm.
So let me do this one, the 10 pi divided by negative 10 pi divided by 3. So do it, start over again, right? So my axis, and I want to draw my circle, my unit circle. All right. So we start off the same way, right? Actually, I think I need this bigger. Just a little bigger. And okay. So I know my pi over 3, so 1, 2, 3, 4, 5, 6. So we know how these go, right? We need negative 10 pi over 3. So if I go in the negative direction, right, that's a negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, right? All the way around until I get to negative 6 pi over 3, which is my 2 pi, right? So 6 pi over 3, 7, 8, 9, 10. Whoa, not exactly what I wanted. So let me actually do it in green and take this thing off. So 6 pi over 3, 7, 8, negative 9, negative 10 pi over 3. Is up to right there. So this angle right here is my negative 10 pi over 3. Okay, now we get to look for our reference angle, and that is that angle right there, right? Turns out that angle right there is pi over 3, which means my reference angle here in the first quadrant would be pi over 3. So reference angle here is pi over 3. So if I need values for negative 10 pi over 3, I can just look at the numbers for pi over 3 and put them where they need to be, because we know that it is in quadrant 2. Make sense? Stop me if you need me. Negative 450. Same idea. Okay. So we know that one whole turn around one whole spin around is negative 360 degrees, right? Plus another 90 degrees gets us negative 450. So here we go. This angle right here is negative 450 degrees, right? Okay. And it turns out that our reference angle here is that angle right there, which just so happens to be here. So we know that this is our angle right here, 90 degrees. So here, reference angle is 90 degrees. Okay. And the last one, 13 pi over 4. This one's a little simpler. We don't have to do over 6 or over 3 in this case. These are nice little quarters. Right? So we know that these are quarters. So this is pi over 4. Whoops. 4. 2 pi over 4. 3 pi over 4. 4 pi over 4, which reduces down to 2 pi, just 1 pi, sorry, right? So all the way around is 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4. Let me do one more. 13 pi over 4. So this angle right here, so starting here, going around and ending there. This angle right here is our 13 pi over 4. Okay? Now, to the reference angle, right? We just need to look at how big that is. And that is just pi over 4, which means our reference angle is pi over 4. Okay? Okay. The next example that I have spells out like the really good stuff, okay? All of these angles are the angles that are above it, right? So what I want you guys to do now is I want you to find the sine of 510, cosine of minus 450, all of those, okay? And you guys are going to be using the reference angles instead of actually going out and finding these, right? Okay? So I'm going to break you guys into your groups one more time, and then after that we'll do lecture questions, okay? And go.
Helicopter yesterday. That was a not military, but probably like one of those big.
You know what it probably was? It's the medevac.
Mhm.
That's what it's supposed to be. Yeah.
The military does that.
Yeah, that one sounds like you. The military ones sound like a thump. They sound like
They make that sound
the woof. Yeah. The woof.
like really intense.
Yeah. That one sounded like a commercial jet. That sounded like a Southwest flight leaving.
I remember when I was younger.
Mhm.
I don't know what the hell was going on, but the military decided to do an exercise over Santa Maria, and they just dropped a bunch of like guys parachuting down all over. I remember I was yay high, but I remember the helicopters flying around, and I just remember I just remember a bunch of guys jumping off parachutes. Military.
Yeah. And they landed in random parts of the city, or like?
I think so. I mean, I remember down the street, our old apartment, and I was really.
That'd be crazy.
It was like a really hot day. I remember that.
Yeah. Good. Let me bug a couple of these guys. How you guys doing? Yay or nay?
Nay.
Nay.
Mhm.
Why nay?
I don't understand. Okay, so I know what to do with the negative 135, but then I'm like, how do I figure out how it's like what the tangent is? Like, I know the tangent is the opposite over the whatever the adjacent or whatever it is, but I don't know what to do with that information.
Right. So, first of all, what's your reference angle?
Negative 135.
What's your reference angle? The reference angle.
45.
Right. That's going to be 45. So now you get to use the numbers for 45 degrees. So if you go back up to the triangle, where was it?
Oh,
Yeah.
wait a second. It's the 40. I think I know what you're gonna say.
You know where I was drawing triangles on page 3 of your notes?
Yeah, the isosceles one. Oh, so then you would just
Yeah.
kind of do the a squared plus a squared equals whatever, and then the square root and all that.
You don't need to. So that's just to prove them. That's just to find them. We've already found them, right? You just get to use the information for 45 degrees.
Oh, so you just put it over each other, kind of thing.
Right. So I gave you the sine and cosine for, or sorry, the x and y, right, for 45 degrees, which is root 2 over 2, comma, square root of 2 over 2, right?
Mm-hmm.
Those are your two sides of the triangle. And then tangent is just the opposite divided by the adjacent.
Oh, so then it would, let's see. Oh, so then it would just literally be root 2 over 2 divided by 2 over 2?
Yep. Root 2 over 2 divided by root 2 over 2.
Oh, wow. That was actually really easy and I didn't understand it.
Yeah. No. You hesitated, which is okay. I mean, everybody does it. But you had it. You had it.
Oh, good.
The hard part's finding the reference angle.
And that's easy as shit.
There you go. There you go. Okay, I'm gonna bug other people. You guys good? You guys not good? You guys pulling out your hair yet?
I don't know. I think with the top ones, it's
Yeah.
pretty easy. So with the bottom one, the tangent of negative 10 pi over 3,
Right.
I got my reference angle to be pi over 3 or 60 degrees.
Yep.
Is that correct?
Yeah.
For the next one, the sine 17 pi over 6, I got my reference angle to be pi over 6 or 30 degrees.
Hold on. I'm doing math in my head. Let me see. 18. Yeah. Pi over 6. Yep.
Yeah. So like 12 pies. Or wait. Yeah. Okay. Cool.
Yeah.
Because 12 pi would be one full iteration or
One
half.
whole spin.
Yeah, and then 5 more would put in the second quadrant.
Right.
5 pi over 6
Right.
is the same as pi over 6. So that's correct rationale,
Yep.
right?
Right,
Right.
right. So your reference angle will be pi over 6. So now you get to use the information for pi over 6.
Yeah. It's just a trip counting the circles. They're counting.
That's the hard part, right?
I mean, but yeah, I got it. I think.
Cool.
We'll see.
Awesome. Okay. You good then?
Yeah, I guess. Yep.
You guessed.
Sure.
Yeah, no. I mean, this is all new stuff to everybody, so
Yeah.
yeah.
Cool.
But you got the right idea.
Cool.
Okay.
Yeah.
Okay. I'm gonna bug Diego's group. I'll see you guys back in the thing in the main. Yeah.
Okay.
You guys.
So I think I found the cosine of 450.
Yeah.
I think it's just 0 because it's 90 degrees, right?
Right.
Okay. But for the sine of 17 pi over 6, I got 1/2, maybe.
Yep.
Okay, and I looked
Yep.
back at the I don't know, when we were doing the 30, 60, 90 and the
Right.
45, 90, did we have to reference that in order to find it?
Yes.
Okay.
So I'm guessing that's what you just looked at it and said, oh, those are the values, and we're done.
Yeah, it was at the 30° the pi over 6,
Right.
and then sine is opposite over hypotenuse, so it'd just be 1/2 over 1.
Right.
Okay. That's what I
Yep.
got.
Okay. All right, I'm gonna bring you guys back. That wasn't that bad, right? Wasn't all that horrible. Okay. In the interest of time, because I want to get you guys practicing your doing the lecture questions for a little bit, I want to give you guys a little more than I want to give you guys about 20 minutes for them. I'm going to do the same. So the reference angles that I have up here are equivalent to some of the angles that are down here, right? So for the cosine of 330, right? We already found the reference angle, that being 30, right? So finding the cosine of 330 is equivalent to finding cosine of the 30 degrees, right? And for that, I think everybody did this by and large. Please don't solve them again. I've already done them for you. I've given them to you right here, right? So we need just cosine of 30, which we know is that one right there. So it's just root 3 over 2. Okay. Tangent of negative 10 pi over 3. We found the reference angle. It's pi over 3. So this is equivalent to tangent of pi over 3. Okay. Now, tangent of pi over 3, that one is the x over y, right? So we're going to go back up here to our triangles, right? And we need pi over 3. So we need this set of values. Come on. So we need this set of values up here, right? So it's going to be the x over the y, so or the opposite over the hypotenuse. Okay, so it's going to be 1/2 divided by root 3 over 2. My tablet's acting up. And this reduces to 1 over square root of 3 or root 3 over 3. Okay. Next one. 450 degrees. The reference angle is 90, right? So we get to just use the 90-degree one. Where's that one? Here. So the cosine of 450 degrees is equivalent to the cosine of the 90 degrees. And in that case, that is 0. Same thing, we're going to go up and look at our values for our triangles from page 3, and that's where we're going to find them. And then lastly, 13 pi over 4. The reference angle was pi over 4, right? So this is equivalent, this is why reference angles are so useful. This is equivalent to the cosine of pi over 4, which is root 2 over 2. Okay? Okay. I want to give you guys maybe I'm going to give you guys maybe 10 minutes to finish this. This should be really, really quick. I don't think I added much more. Yeah. I want you guys to finish the lecture questions really quick in about 10 minutes. In particular, I want you guys to try to fill this thing out. This is now what we call the complete unit circle. This is the thing that you're going to be referencing like crazy. This will become our Bible, our Quran, our Torah, whatever you want to call it for pre-calc from here on out until the end of the semester. Yeah, whatever makes you feel good. Okay. Okay, so I want to give you guys 10 minutes to finish this up, and then I'll start section 5.3. So maybe we can get some headway into that before class is done. I did.
I want to have it in front of me so I can say, figure out myself. Maybe I should have a snack. No. My ergo chair. This.
I would say you want to go get a chair.
Honestly, you need to get a new desk.
No. Why?
It's not appropriate height.
What's not an appropriate height?
The desk.
How do you know?
Because it's like it doesn't let me scoot in all the way because that thing is on the way.
This thing is, but it's the only thing that can put that key over here.
I know, but
We'll get you a desk. I want my desk. Huh?
I'm also from that.
Well, I don't know. The storage. What's for lunch today is a good question. Pretty juice. I'm gonna have Togos. I haven't had that in a long time.
Do you know how we could find the reference angle for 100 degrees?
The same thing, right? It's the same process. You just don't have values for it. Does that make sense, Edlin?
Okay, so would it be 80 degrees?
Huh?
Would it just be 80?
Mm-hmm.
Oh, okay. Okay, got it.
Does that make sense?
Yes. Okay.
It's the equivalent angle in that first quadrant, whatever it is.
Okay, got it.
Oh, we can do this. Scramble, scramble.
For the circle, how do
Mhm.
we, for the points on the second quadrant, would it kind of just be like the reflection but negative?
Exactly. So you just need to treat the things that are supposed to be negative as negative, right? So in the second quadrant over here, right,
Mm-hmm.
all the y's are still positive, but the x's are now negative, right?
Oh,
And you use
okay.
the same angles from quadrant one, hence the reason why they're called reference angles.
Oh, so the first one would be -1/2 and then square root 3/2?
Right.
Okay, got it.
All right. In the interest of time, I want to get started on 5-3. Okay. But before I do, okay, now I know this is basically giving you guys the answers to the lecture questions, and I'm okay with it for 5-2. But what I still want everybody to do is understand why the numbers that you get for the unit circle are the numbers that you get. So a lot of the work that we just did covered, whoa, undo that. A lot of the work that we just did covered a lot of that stuff, right? We sort of completely defined everything in there. We didn't define the rest of the stuff that went all the way around, right? But as Edlin had just pointed out, right, all of this stuff is based off of a reference angle. So if you have this quadrant right here filled out, right, then you can get the numbers for over here. You just need to make the corresponding things negative, right? So over here, all the x's are going to be negative, all the y's are going to stay positive, right? Down here, everything is negative, right? And then over here, everything, or sorry, cosines are positive, the x's are positive, but the signs are negative, right? So it all boils down to that, okay? Now, what I want to give everybody, so I put it here, I'll put it up on the Canvas page in a little bit. I give you guys a blank one, a big, huge blank one, just in case you need to see the numbers a little clearer. You want to reference something that you made, which is perfectly fine. So this is for you guys to have and to fill out and to post up right next to your NSYNC posters or your Backstreet Boys posters or Metallica posters, whatever, right? Post them up somewhere. Like I said, I'm not going to make you memorize them, but you will be using them so much that eventually you will, okay? So this is something for you guys to fill out on your own. Yes, Joe.
Quick question for you. So like on the at 135 degrees in quadrant 2,
Mm-hmm.
the cosine, it's going to be negative square root of 2, not the square root of negative 2, right? Are we doing
Right, it's going to be negative square root of 2 divided by 2.
and not the square root of negative 2 divided by
Right,
2.
it's not the square root of negative 2. You
All right,
can't
cool.
have this. Yeah, got it?
Thanks.
Mm-hmm. So back to what I was saying. I'm giving you guys a big version so you guys can post up somewhere, fill it in for yourselves, and have it somewhere looming around. Like I said, we're going to be using this repeatedly, okay? And then on top of that, I'll put this up shortly in a little bit. The math lab had, well, the first page is actually this page, had a bunch of helpful trigonometry formulas. A lot of this stuff will be foreign to you up until maybe 2 weeks from now, okay? Like I said, we will slowly be covering the things that are on this in this packet. This is actually supposed to be a little trifold. So, for example, what I mean by that is, if you guys look at my camera, there it is. It's supposed to fold up into a nice little, oh, my background. Frisco's nice, but so it's supposed to turn into like a little trifold little thingy where you can, ooh, you see that? Okay, if you print it back to back, like two-sided, you should be able to get like a little thing like this. Like I said, a lot of this stuff will seem very foreign to you right now. We will start covering the stuff bit by bit as we move along in the next maybe 2 weeks, 3 weeks, okay? In there, a nice good copy of a unit circle with all the degrees and all the radians on it, okay? So I would say sometime soon, within the next maybe, I don't know, week or so, maybe hopefully by the beginning of next week, by Monday, try to print one of these out so that we can reference it every once in a while. You will need it a lot. I'm not kidding, a lot, okay? So just make sure you print it out.
And where can you print that out at?
I haven't put it in the files yet. I just put it in the I put it in the notes for now.
Okay.
I'll upload it to the notes. Excuse me, so that everybody can have it, so that everybody can print it out later.
And also, do you
Okay.
know for the chapter 5, are we doing up to 5.5 and then we're doing 3.6 through 5.5?
We're gonna for the test, right?
Yes.
For the test, I am thinking I'm gonna leave off 3.6, 3.7, the last couple sections from 3, and I
Okay.
just want to do 4 and 5.
Okay, perfect.
And for 4 and so for 5, I'm only gonna cover up to 5.4. We're not gonna do
Okay,
5.5 from the book.
perfect. Awesome.
Yeah.
So we're doing 4.1 through 5.4.
4. Yeah.
Okay, perfect. Awesome.
Got it? Okay. So, this is this is what the math lab used to have. This is actually one of the things I actually stole it from Brentwood and made a couple modifications to it myself so that we can use it at LMC at the Pittsburgh campus. So it's a really, 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 really handy resource for everybody. So handy, the calculus students regularly come back down to the math lab and say, hey, you guys got any more of those trig things? And we're like, oh yeah, here you are. So it's got a lot of formulas on it. Use it freely. You will be using it freely once we get farther and farther into the trig stuff, okay? All right, so. Did I? Yeah, I did. All right, so at the moment, we've just covered sine and cosine, okay? And we did a little bit of stuff with tangent, right? There are 3 other functions that we're going to cover today. And those are the last 3 trigonometric functions. These are sort of like the more important ones, okay? And those last 3 are secant, cosecant, and cotangent, okay? They're pretty easy to remember, though they do, one of them, well, 2 of them, have you'd think it'd be something, but it's not. We'll cover that right now. So let me just go ahead and cover the first 3 that we have, right? So, whoa. Sine of some angle theta, right, is opposite over hypotenuse, right? And if we use our x's and our r's, right, so it's the x divided by the radius, okay? Cosine of some angle theta is adjacent over hypotenuse, right? And that is equal to the y divided by the r. And the last one that we covered was tangent of theta, which is the opposite divided by the adjacent. And if we use as our x and our y's, that's the x divided by the y. Cool? Okay. So here come the last 3. Okay? It turns out, actually, I'm going to start out with the one in the middle. So secant, right, of an angle theta, this is what I mean by you'd think that they would be something, but they're not. So secant actually is sort of related to cosine. And that is going to be r divided by y. The other way you can write it is 1 over cosine of theta. So if you grab this thing and do 1 over y divided by r, you end up getting the r divided by y. So that's why we call it 1 over cosine. Okay? And the other ones work out the same way. So cosecant of an angle theta is r over x. The other way you can call it is 1 over sine of an angle theta. Right? Okay? And then lastly, cotangent. Cotangent of an angle theta is equal to y over x, which is also 1 over tangent of theta. Okay, now there's one quick identity that I haven't shown you guys. They didn't want to, r over y. There's one identity that I haven't shown you guys. So essentially tangent is also sine of an angle theta divided by the cosine of the angle theta, okay? And the way that that happens, so we see that it's equal to x over y, right? So it turns out if you grab this divided by this, if you grab sine, which is x over r, and cosine, which is y over r, and you divide them, you get x over y. Hence the reason why we get tangent is equal to sine of theta divided by cosine of theta. Okay, that rounds out all the trig functions that we're going to be playing around with for the next 2-3 weeks. Okay, so with that being said, we can go ahead and now find all 6 functions for a particular point, right? And it goes just as you would expect, right? So sine of an angle theta is going to be the y, so that's going to be 1/2. Okay, the cosine of an angle theta is equal to negative root 3 over 2. And the tangent of the angle theta is going to be the sine divided by the cosine. So it's going to be 1/2 divided by negative root 3 over 2. Okay, and that reduces to negative 1 over the square root of 3, or negative root 3 over 3. So we have 3 of them already done. 1, 2, 3. Okay. Now the last 3. Okay. So cosecant of the angle theta is going to be 1 over the sine, which is 1/2. Right? And this reduces to 2. Okay. The secant of the theta is going to be 1 over negative root 3 over 2, which is 2 over negative root 3. We don't like square roots on the bottom. So let me actually move over here. We're going to multiply the top and the bottom by root 3. Okay, now what the heck does that do? The bottom, right? Square root of 3 times square root of 3 is 3. So now we have this negative root, 2 root 3 divided by 3. Okay, and then the last one, we got tangent of an angle theta. So we can do the sine over the cosine, right? Or we can do just 1 over tangent. Okay, so I'm going to do the sine over cosine one just so that we can get that worked out. So the sine, or sorry, not tangent, I need cotangent. That's my bad. So we can do the sine over cosine, or we can do the 1 over tangent. Okay, which is So let me do the 1 over tangent. So it's going to be 1 divided by square root of 3, negative square root of 3 divided by 3, right? And this is 3 divided by the square root of 3. This is going to be negative, right? And this reduces to negative square root of 3. I should actually add in y. There we go. Okay, so negative root 3 times root 3 over square root of 3. So what I did here is this times that is still equal to that. Does that make sense? So I broke up 3 into its square roots. So the math in this direction still works out, hence the reason why I can do this. Okay? Now, once I have it in this version down here like this, I can cancel out root 3's. And I get left with negative square root of 3. I'm pretty sure some of you guys were like, well, how do you get that? Oh, there you are. Does anybody, did I lose people?
Yes.
Yep.
Where?
Yes.
So
Where? How?
you just multiply the top by square root of 3?
I didn't multiply the top. So what I'm trying to do is, so the square root of 3 times the square root of 3, right? That is equal to 3, correct?
Yeah.
Yes.
Right? So let me write it down over here. So square root of 3 times square root of 3 is equal to 3, right?
Mm-hmm.
So a lot, like nearly exclusively for this entire class, I've been using this in this direction, right? And that's how I've been reducing it, right?
Yeah.
But now I'm using it in the opposite direction. I'm breaking down the 3 into the 2 square roots.
Okay. So if we had just divided top and bottom by square root of 3, would we get the same answer? Or no?
Yes.
Oh.
So how about I do it the other way? How about I do it another way in terms of multiplication? Okay. I see what I think I see what you're trying to say. How about we do it that way? So what I put down is equivalent, right? But I'm going to do it the way that you were doing. So we're going to multiply by square root of 3 on the bottom and the top. I think this is the way that you were trying to do it, right, Evelyn?
Yeah.
Yeah. So if we do this, this actually makes more sense because we've done it this way before. Duh. Okay. Minus 3 square root of 3. That's the top. And then root 3 times root 3, that's still 3. Right? And what we have here now, right? This cancels the 3 from up top. And now we get left with the same answer, negative root 3. How's that look?
Makes more sense.
Makes more sense. Thank goodness. Woo. Okay. Makes more sense. Woo. Okay. Awesome. Okay. So does everybody see the, so we're done at this point. So cosecant, secant, and cotangent. We have all 6 functions for 1 point. Does that make sense? Okay, I want everyone to practice a little bit. So I've got one quick check here. I give you guys a couple points. I'll give you guys each 1 point. And I want you to do the same thing that we did up here. Okay? Find the 6 functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay? I'm going to break you guys up into your groups. Your group room tells you what problem to do. Okay?
Professor, can you put it up a little bit so I can see the first part?
There?
Yeah, thank you.
Uh-huh.
Even though I got nothing.
Yeah. You guys doing okay for now?
Yeah.
Professor, I understood nothing from that.
Okay, what part?
From the very beginning.
Okay, so a lot of this is compiled from section, what is it, 5.1? Or no, sorry, 5.2. So do you understand the first part, that sine is equal to x over r, cosine y over r, tangent x over y?
No.
Did you get the SOHCAHTOA stuff?
Yeah, kind of.
Yeah, okay, so if you go back to section 5.2, right, and to the notes from there, it's from the very beginning. I give you the equivalencies for all the first 3 for sine, cosine, and tangent.
So it's like plugging in all the stuff?
Yep.
Okay. Mm,
So specifically, you need to know that. Am I sharing the screen with you already?
no.
No. Okay. Let me go back to.
What's kind of confusing is the opposite and the hypothesis, like where each one is at.
That depends on your angle.
Okay.
So I should be sharing it now, right?
Yeah, I see it.
Yeah. So depending on where your angle is, right? That's going to determine what's called adjacent and what's called opposite. Does that make sense? So let me actually go over here, right? And if I'm going to do a random triangle here, right? So if this is my angle right here, theta, right? Then this would be my opposite, and this would be my adjacent. This long leg right here is always going to be my hypotenuse. The long leg is always going to be the hypotenuse. It's the other two that depends on the placement of your theta, of your angle. Does that make sense?
Yeah.
So if my angle now is up here, right? Rather than over here, then now this is my adjacent and this is my opposite. Got it?
Yeah, I kind of get it.
Okay. All right, I'm gonna go bug another group.
Okay.
I'll come back. Yeah? $24. You guys?
Mm-hmm.
Thumbs up, thumbs down. Me?
Meh.
Me? Okay. I can dig it. What part's me?
The part after, so I know it's easy to figure out, okay, sine is 2√5/5, then all that, but then how you have to kind of like simplify it down. That's where I'm kind of like, okay, this is getting a little bit.
Yeah. There's a little bit of how did I say it? There's a little bit of math involved. A little bit of arithmetic.
Mm-hmm.
Yeah. Okay, I'm gonna mess with another group really quick before I call you guys back in.
Okay.
You guys, thumbs up, thumbs down.
Oh,
I think we got it.
Okay.
got it.
Okay.
I just have
It's
a
a-
hard time remembering that we can't have square roots in the denominator. So
Yeah. Yeah, there's a fair amount of some of the other groups were saying that there's a fair amount of fractiony stuff that is
Yeah.
so
Yeah, that's what I'm getting to. I'm like,
I got to get you guys to practice. So this is one of the times I'm making you guys practice. So yeah, don't worry too much about it. Yeah.
When we multiply like the top by the square root, we don't actually multiply them together, right? We leave them like separate.
yeah, as a square root, yeah.
Okay.
Mm-hmm. Okay, I'm gonna call you guys in because class is almost over.
Okay.
Okay.
Mm-hmm.
Let me see. No. I have live hours. From 1:15 to 2. Yeah. Okay, fine. Get chips. All right, you guys ready for the last bit? Where the heck? There we go. Okay, let me finish up with a couple of examples from here. We'll finish up the rest on Monday. Okay, so I'm going to go ahead and do these two just to show how the math is going to work out, right? So sine for this one is the 4/5, right? The cosine of the angle is the 3/5. Those are two easy ones, right? Now, tangent of theta. Then now we have to do the sine divided by the cosine or the x divided by the y. So here's where we have to do 4 over 5 divided by 3 over 5. Okay. Now, a lot of you guys have been saying the arithmetic behind it. So messing around with multiplying and dividing fractions, right? This is equivalent to 4, let me actually write it, 4 over 5 divided by 3 over 5, which is equal to, do you guys remember how to divide fractions? Is you flip the second one and turn it into a positive, into a multiplication, right? So it's going to be 4 over 5 times 5 over 3, okay? And it's at this point where we can do canceling. We are left with 4 divided by 3. Got it? So these 3 right here are the harder ones to figure out, because once we get to now, once we have these, we can use the definition from cosecant, secant, and cotangent to flip these around how we need it. Yeah. So secant of theta is the 1 over the cosine of theta. We know cosine is 3 over 5, so 1 over 3 over 5, which is 5 over 3. Cosecant of theta is 1 over the sine of theta, which is 1 over 4 divided by 5, which is 5 over 4. And then lastly, cotangent of theta is 1 over tangent of theta, which is 1 over 4 divided by 3, 3 over 4. And those are the last 3. That one, and that one. Did I lose people? If I lost people, that's okay, because class is over, which means I get to cover this one on Monday.
And you'll be posting the video for this one on YouTube still, right?
Yeah, the YouTube video for Monday, it took forever to convert. It finished like yesterday night. So same thing, I'm gonna post the videos for this one tonight in a little bit. Hopefully
No problem.
it'll convert faster.
Perfect. And then also all this, I have like up to like all chapter 4 done. I memorized all of it, so I'm good there. Chapter 5, all the homework will also explain the process for all this, right?
Yep.
Perfect.
Yep. So again, I think I didn't put up your guys' stuff for chapter 5 until this morning. I was like taking a shower. I was taking a shower and I was like, oh shit, I forgot chapter 5 stuff.
I also had a quick question as well. I finished all the chapter 4 lecture questions. Do you want me to send them on like a text message picture to you, email? Is there a certain place you want me to send that to you at?
Yeah. So so all of the chapter 4 lecture question. Oh, did I not make? I don't think I made the things for them yet. Then
I think they actually might be. Let me check it out right now. I'm actually on Canvas.
It's one of those where you have to do the online submission. So once you have it done, take a picture of it and upload it to the Canvas to the
I see them right here. Yeah, I got you. No, I see them right here. So you just submit the assignment through a picture and then just put it on there?
Yep.
Perfect.
That's it.
Awesome.
Got it?
Also, I feel like these chapters are a lot easier than the last test we took. I don't know.
Yeah. Which is a good thing for you guys, because if this stuff is easy, right, this is half of the stuff that's going to be on the test.
That's honestly good news, because I felt like I had more difficulty on some things on the last test than
last test, yeah.
Chapter 4, I was just like surprised, like it's just like moving shit mostly, and I feel
Yeah.
like it's not a lot of math work or not a lot of complex math work. Except if I think it was, I forgot what chapter it was. One chapter kind of threw me off a little bit in chapter 4, but
Yeah.
I ended up getting it.
Cool. Cool beans. Cool beans.
Sweet. All right. Perfect. I will
Okay.
see you next Monday.
Next Monday. Yep. All right, you guys. There's a chat question. Let's see. Flip it.
Where do we turn in the lecture questions again?
So if you go to your assignments in peace out, man. I'll see you on Monday. If you go to your lecture questions, if you go to the assignments in Canvas, there should be a link for each one of the lecture questions for each chapter.
Oh, I see. Okay.
Yeah. So in there should be a button that says. So if you click on it, there's going to be online submission. So the best way to do it is if you do it over your phone. So if you do it over your phone, hit on your phone, hit what is it? Submit. I think it's like, what is it? Assignment submission or whatever. There's a button there that says submit assignment or something. You hit that, it'll give you an option to access your phone, your phone camera. So that way you can take a picture of it and submit it that way. So the best way to do this is do it online or do it from your phone.
Assignments. Then the one that says section, okay, so section 4.1 LQ, that one?
Yeah.
And then you just press it and then...
There should be an option in there for submit assignment. Yeah.
Okay.
So you click that, and if you do it all over your phone, it'll give you the option to use your phone camera. That's what I'm saying. The best way to do it is if you can do it over your phone.
Okay.
Otherwise, you're going to have to scan it and this other stuff, and that's too much.
Okay.
Cool.
All right. Okay, thank you. See you next week.
I'll see you next week. All right. Ethan, we're good? Okay, so I need to grab lunch before I go to my office hour or to my lab hours. So if you got any questions, I'll be in the lab at around 1:15 about. And then I have office hours from 2 to 3. Okay, so if you have any questions, come at me then. Cool. Okay, and otherwise, besides that, I'll see you on Monday.